Hey folks, I've tried to make a really concise video here on what we're doing. So I appreciate you watching it if you're at home and not feeling well or whatever your situation is, if you're on vacation early. In class, we're going to just talk about it and do it together. We're going to do these problems together. So we're not going to watch the video. But I'm making this for you guys that can't be here in class. So anyways, what are we doing? We're going to try to solve a quadratic equation, uh, and we're going to use factoring to do it. So, maybe the first thing that came to mind is, do you remember like what is a quadratic equation, right? It's like right below maybe this little note right here. Let's put down ax squared plus bx plus c. That's quadratic, right? Now, this guy doesn't look like a quadratic, but if we took, 7x plus 3 and we multiplied it by 2x minus 6, let's see, if I go like that, I get 14x squared. This is the distributive property, right? 7x times negative 6 is negative 42x. 3 times 2x is 6x. And 3 times negative 6 is negative 18. So we've kind of worked some skills up to this point, and I'm just kind of reviewing some of those skills. We've done this before, right? This is not today's work. We've done this already. So 14x squared minus, what would that be? 36x. That's a minus 18. So this is definitely a quadratic, right? But if it looks like this, it's difficult, or at least more difficult, to find what would make the whole function equal to 0. It would be harder to find what's called the roots. So when I say solve, we're gonna find things that are called the roots, which are the solutions, which means what do you have to plug in for x to make the function 0? That's really what our question is all about. What do we plug in for x to make the function the function equals 0? All right, so that's our task. Now, if it's in factored form, I said it's way easier than if it's not in factored form. So let's look back. This originally was where we started, and it's equivalent to the 14x squared minus 36 minus 18, but it's way easier to solve this one. Now, you might think, okay, well, just tell me how to do it. But I wanted to have you fully understand what's going on. So I'm going to show you a graph real quick. All right, I've put it into Desmos for you, 7x plus 3 times 2x minus 6. Let's just confirm I've got the right thing in there, 7x plus 3, 2x minus 6. Yes, I do. So I'm looking at the graph. Yesterday, we talked about finding the solutions by graphing, and you can see if we stick 3 into the equation, we get 0. And if we stick, oh, what is this number? Well, let's investigate that a little bit, okay? So when I look back over here, why was x equals 3 one of my solutions? So let's look at this guy right here. If it was equal to 0, the whole factor, then I'd have 0 times whatever would be generated over here, some number. I'll put number in here, or maybe abbreviate it. I'll fit it in. So number times 0, hey, that's got to be equal to 0, right? Check mark. So what would make 2x minus 6 equal to 0? Well, if I add 6 to both sides, I get 2x equals 6. If I divide by 2, I get 3. Hey, wait a minute. Let's look back at our graph. See, I got 3 right there. So all it takes is setting this factor equal to 0. Now, having the factor equal to 0 is way easier than having the whole quadratic equal to 0. Let's think about that for a second. Having 2x minus 6 equals 0 is easier for me to solve because all I had to do is add 6 and divide by 2. If I had 14x squared minus 36x minus 18, you can't just move the 18 to the other side. There's no process quite as simple as just solving this equation right here. So the factors break it down into little parts that we can solve separately. Okay, so we've got 7x plus 3 over here, 7x plus 3. I'm going to set it equal to 0 also, because if I had 0 here, all of this stuff was 0. Who cares what this is? Because 0 times anything is 0. That's called the zero product property. We don't need to worry about that right now, but it's a pretty cool feature of 0. 0 times anything is equal to 0. So let's look back here. So 7x plus 3 equals 0, right? And I'm going to subtract 3 from both sides. Okay, so now I've got 7x equals negative 3. I divide by 7, and I get negative 3/7. Okay, well, no, wait a minute. Let's put our graph down real quick. What did that graph look like again? Okay, it looked like that. Okay, so I see it. Let me put it in red just so it looks just like Desmos. So it kind of came down like this. It's a parabola, right? Don't mean to gap that right there. And so what was this answer over here? It was 3. That is 3. Well, that came from this guy right here, check mark. This answer over here was like negative 0.4 something or other, right? So let's check out negative 3/7 for a moment here. Let's go equals, let's see, negative 3 divided by 7. Hey, look at that. Negative 0.4285 something. What was this again? Negative 0.429. So they're just rounding to the thousandths place, right? So let's go back over here and we'll put an approximation down too, just to kind of confirm things. Negative 0.429. That's what this number was right there. Negative 0.429. So having factors helps us get the zeros or the roots. So another word for root is 0, because we're finding what would we plug in for x to make the function equal to 0. Let's look at a different situation. Let's say I had x squared equals 36. Okay, so if I subtract 36 from both sides, and then I try to factor this is a difference of 2 squares. I don't really want to be in red. So I try to factor this guy, and I get x minus 6, x plus 6. This was on our last chapter test, right? The difference of 2 squares, factors like this. So I should have 2 answers, x equals 6 and x equals negative 6. Let's see if that's true. When I come back over here, I'm going to, let's see, turn this guy off. Can I turn it off? Yeah, there we go. And then I go open this guy up, turn it on. Does it go through negative 6 and positive 6? Sure does. So my two solutions, where'd my problem go here? Oh yeah, here it is. My two solutions are negative 6 and positive 6. Let's put a little graph down. Let's mark them. Negative 6, positive 6. If I stuck a 6 in here, 6 squared is 36. Negative 6 squared is 36. Now, wait a minute. You know what? Some of you guys might be saying, you don't have to factor this one to solve it. You could just take the square root. So if I take the square root of 36, the principal root is 6, okay? But I only get the positive. I only get the positive 6 right there. You notice that? So what we do to fix that issue is we put plus or minus, plus or minus, plus or minus. And so you can do the problem that way. It's a pretty cool feature. If you just have an x squared and then a constant, you can move the constant to the other side and take the square root. If you have a middle term, like I did here at a negative 36x, a linear term, you can't just move the 18 to the other side. It just won't work. Okay, like this one right here is going to have a middle term. So let's do this. Put the video on pause. You try this process right now. And I want to tell you the first step is you got to move the 27 to the left side of the equation, okay? So I'm going to move the 27 over by subtraction. I'm going to subtract 27 from both sides. These are not like terms, so the best you can do is x squared minus 6x minus 27. You try to factor this right now. If you're like, wait a minute, Nelson, I can't factor that. You need to teach me how to do that. Well, again, let me just kind of remind you that we did this last chapter. So you take the negative 27, you put it here. You try to think of two factors multiplying together to give you negative 27 and adding together to give you negative 6. So if I did negative 9 times 3, that would give me negative 9 plus 3. That gives me negative 6, right? So these are definitely the factors I want. Okay, you try it. Put the video on pause. Try to finish this problem off. Hey, thanks, everybody. So what you did next was hopefully you went x minus 9, x plus 3, and you say, okay, well, what's going to make this factor equal to 0? Well, if x was negative 3, what's going to make this factor 0? Okay, well, if x was positive 9. So sometimes people start saying, wait a minute, I just take the opposite of the number that's sitting here. Let's think about that idea for a second. If I put 9 in for x, positive 9 minus 9 would give me 0. And if I have 0 times, who cares what's over here? I get 0. 0 times anything is 0. If I put negative 3 in here, do I get 0? Yeah, of course I do, right? So when it's nice and easy like this, you probably don't need to do any work. However, if it gets a little bit more difficult, all you do is you set the factor equal to 0 and you solve it. So how do I solve this? I just subtract 3 from both sides, right? and we end up with x equals -3. That's how I got that -3 for my final answer right there. Let me circle that. Okay, let me circle this, and let's go check our answer. See, we're expecting to get 9 over here and -3 right in here, and an upward opening parabola because it's a positive x squared. So halfway in between has to be my line of symmetry. So I'll just guess at where I think the vertex is going to be. All right, try to make it look like it goes smoothly through there, not like in some kind of jagged point. All right, let's look over there and see if we got the right answer. So let's turn this guy off, hide it, open this one up, and let's see if we got the right answer. So we got -3, yes we did, and 9. Those were our two answers. See, -3 and 9. Hey guys, thanks for watching my video. If you were in class, we would go to the whiteboard with our partners and we would try these 3 problems. I'd review it with everybody. I'd give you as much time in class as possible to finish the homework. So good luck. Love you guys. Hope you're doing okay.